Okay, so we're discussing about publication quality graphs and plots with Origin Pro. In the same line, we have discussed uh, about how to draw bar graphs. We have discussed how to draw bar graphs with error measures. We have discussed how to draw scatter graphs. We have discussed how to draw multiple Y plots. And we have also seen the importance of normal probability plots and how they are also similar to the histograms, the normal probability curves that we draw on them. So we'll draw two very specialized graphs in this particular session. We'll discuss how to draw box plots, and we'll also discuss in the later half of this session how to draw surface and contour plots. So basically, now let us first discuss the box plots. The box plots basically um, combine or they concise a lot of data in form of this kind of boxes. Okay, so these are very specialized statistical plots. So suppose say in this particular example that I have here, I'm using two different methods. Suppose say I'm using method one. Let me say them as method one and method two. I'm using two different methods, method one and method two, and then I am comparing the output of these two methods by using box plots. So basically, in this particular diagram, what I've done is that this is the first box plot, this is the second box plot. So you see that the name box plot is because it looks like a box and there are some whiskers here. These are called as the whiskers. These lines are called as the whiskers. And just near the box plot, this is not a traditional box plot. This is the kind of box plot that I like to draw. So this particular box and this particular box, these are known as the box plots, and this is the data scatter that I like to put near the box plot. This is a traditional box plot. This is how a traditional box plot looks like. And in this particular diagram, I have enhanced the box plot by also showing the data scatter, and here also I have shown the data scatter. So the box plot along with the data scatter gives us a lot of information. For example, just by looking, because these two methods or these two algorithms are run for the same example, so you see that you see some distinct features here. You see that at very this particular algorithm has very low number of low values and very high cluster of high values, whereas in this particular method you see that the number of low values is very small, and similarly the number of high values is also not that very huge, but the mid-range values are a lot. Okay, so by looking at the this kind of data clusters, or by looking at this kind of data cluster points, we get some more information about the algorithms or the methods that we have used. So that is the importance of this kind of box plots. So what are the components of a box plot? Let us first see it here in this diagram. I have displayed it here, that what are the components of the box plot. So generally, we measure the this box plot takes the data that is there and arranges them in front in uh, form of percentile. For example, suppose say both this data and this data has been ran for. So each of this data, each of this box plot, show the data of 50,000 uh, 50,000 data points. So here it contains 50,000 data points, it contains 50,000 data points, and each of this contains 50,000 data points. So let us look at here. So what does it tells about the 50,000 data points? So the box structure that you have here, that is the range, that is the total data that is lying between 25 percentile to the 75 percentile. Okay, so the total data that is there between the 25 percentile to 75 percentile value means if we arrange them in descending order, so starting from the 25 percentile to the 75 percentile, the data that is there, it is displayed in form of this particular box. Okay, so higher the thickness of the box, it means the more the data is scattered in the 75 to 25% range. And this is the median line, the line that you saw here, the line that you see here in between the line that you see here, that is the median line. The median basically is, if you suppose say for this kind of example, if suppose say I have the 50,000 iterations and I arrange them in a very descending order or ascending order, then the data which is exactly at the center, For example, if suppose I have 50,001 number of values, so the data which is at the 25th 25,000, the data which is the 25,000, that is the median line, or that is the median value. So that median value is being depicted by this particular line. And then we also, why is this data plot, why is this box plot important, is that we also see the mean value here. The mean of the mean is the average. If we suppose say in this case, if we're saying that we have 50,000 values, so the small box that we see here, that depicts the average of the 50,000 values. So you see that the average value is here. In this case, the average value is here. In case this, the average value is here. So you see that this particular graphs contains a lot of statistical information within it. For example, here, just by looking at this particular diagram, when you see that the median is above the mean, okay, here you see that the mean and median are almost on the same point. So here it would mean that the data cluster is more at the around the average. But here you see that the data cluster is not around the average, but it is above the average. That is why you see that the median line is above. Okay, more number of values in this particular data cluster have high values. That is why the median is above and the mean is low. If it is opposite, if suppose say the mean is up and the median is low, then it would mean there would be a lot of cluster of the data in the lower part. Okay, so that is why this kind of graphs are important. And the last information that I have given here is the outliers. Outliers are basically the extremum points that we have, which do not fit a particular trend. So in this case, we see that there are this particular are the outliers here, these are the outliers here, these are the outliers, and so on. And the whiskers, the lines, the straight lines that you see here, these lines that you see here, these are known as the interquartile regions. Okay. So this also show 25% of the data. So now let us see how to make this kind of graphs in Origin. Let us go back to the Origin. Suppose say I have the data for this same thing. I have the data here. Suppose say you want to compare two different algorithms, or if you want to compare two different sets of experiments that you want to compare two different sets of experiments that you have. So you have the readings from both the experiments. You need to put them in the Origin like this. And what you should look at here is that, again, in this kind of graph, there will be no X, only there will be Y. So let me set this to Y. So I have two different Y columns here. And now I'll try to draw a box plot. I will select both of them. I'll go to the plot. I will go to the statistics, and I'll draw a box chart. And by default, it will look something like this. It will look something like this. And if we want, we can improve this further. Just let me click on this. Just click on this part on any of the lines. You click and you see the pattern is here. Just let me try to improve them. I like them to have a little more width, so let me increase the width. And I want a little more spacing. Suppose I want the spacing to be high between them, so the distance between them is high, because I would like to have the data clusters here. So I like the spacing to be a lot. So I have increased the spacing from here. Now let me go back to the box. Again, in the box itself, you have different kinds of box. This is a traditional box. Okay. This is a traditional box that we have. We can have, instead of the box, we can have only the data clusters. Let us apply. You see, we have only the data clusters. And we can also have the box and the data overlap. The box is there, and on that we are overlapping the box. So this kind of graphs are very difficult to draw when you are using Excel. But here in Origin, all these particular graphs are in a pre-template form, so you can very easily draw. Let me click on this. So you see, this is a very nice looking graph, and same thing you can have it on right. So here what you see is that the boxes are on this side, on the left side, and the data cluster is being shown on the right side. Again, we can have a lot more information. You can try out this. You can switch on the outliers, and it will show the outlier values here. If you do not want, you can close them. And even in the box also, even in the, this is the group data. This is similar like all the other graphs that we have done. In the data, if you want to increase the thickness or decrease the thickness of these dots, you can go here, and in the symbols, suppose say since it is a lot of data, so let me reduce the symbol size. Okay, so in this way, and if you want, instead of the solid, you can make them open. So you can play around with this and you can improve your graph. And if you want any other information, so this is the type of symbol they are using for this kind of information. And if you want some kind of pattern to fill this, you can also do this. So basically, these graphs are useful when you are comparing two different, three different, or n number of different methods or n number of different data sets, and you want to see that okay, statistically, what is the difference between these data sets, how their mean mode, how their mean and the medians are varying, how this data is spread across the different is total range. So this kind of information you get by using this kind of box plots. So let us go back to the PPT. The last, okay. So finally, we'll talk about, hello, yeah. So finally, we'll talk about the surface plots and the contour plots. We'll talk about the surface and contour plots. Basically, the surface plots are 3D plots where we have two different variables and we have a response that is associated with this particular variable, and we try to plot this in kind of a three-dimensional way. And the contour plots say show the same information. For example, this is a contour plot for the same diagram. The contour plots show the same information, but instead of a 3D plot, we show it in a 2D plot, where the two variables are shown in the x and y direction, and uh, the variation in the color pattern depicts the third dimension or the response. Okay, so we'll see how to draw both of them. And in Origin, we can draw them in a very straightforward manner. Let us go to our Origin. Yeah. So for example, I have the data set here. So I have the x variable here, I have the y variable here, and I have a z variable here. So let us click on here and set it as z. I have a z variable here. So there are different ways of drawing this kind of, 3D plots. Uh, because you see, let me show you how much data I have. For example, in this particular case, I have 1369 data points in this, and by using these 1369 data points, I would like to draw this particular diagram. So generally what happens in 3D plots is that the more data that you have, the better will be the accuracy of the surface plot, or the better will be the accuracy of the contour plot. If you have less data, if you have suppose say only 10 data, and with 10 data you try to draw this kind of a surface plot, the prediction or the kind of surface plot that will have will not be a true representation of the actual surface. So it is generally recommended that you have equally spaced data, and you have sufficient number of data so that you can draw this particular diagram or this particular plot. Even if suppose say you have a less number of data, you can increase your data by using some interpolation techniques that are already there inbuilt in the Origin Pro software. So let us see how to improve the data or increase the number of the data points by using the inbuilt interpolation techniques that we have in the uh, Origin Pro software. So let me just click on all of this, and let me go to the worksheet. We'll go to the worksheet, and in the worksheet you'll find we have convert to XYZ, but instead of this we'll use this is convert to the matrix. And there are different kinds of techniques, and each of them has their own advantage. I personally like to use the XYZ gridding technique, because here there are some very powerful algorithms that are here, very proven and powerful algorithms are here. I can use them to improve the or to increase the number of data points that I have. I like to set this on menu, uh, from manual to auto. It basically, the recalculate means if suppose say I change any of the data points here, so my the worksheet or the or the additional worksheet that I'll be creating by this technique, that will be automatically uh, updated. So I like to make this as auto and click on the input, and you can see these are the inputs, and you can go to the gridding. This is a very important option here. So in the gridding, basically what this software will do is that, what Origin Pro will do is that, taking the 1369 points that I have, it will form it in this kind of a grid, in this kind of a XY grid. So the more grid that you have, the better will be the more number of grid points that you have, the smoother will be the surface. If you have very less number of grid points and you try to do a 3D plot, it will be a very irregular kind of thing. And if you have more number of data points, or more number of grid points, and you try to draw a particular 3D plot, the grid will be, or the diagram will be more smooth. Let us see what it means. So in the gridding methods, there are different kinds of algorithms that are inbuilt there in the uh, Origin Pro software. For example, in the gridding method and parameters, we have different kinds of methods like regular. Regular is basically using the same information that is already there in your data sheet. Sparse is there. Sparse is a kind of manipulation of the data that you have to increase it. We have then Renka Klein method, we have done Shepard method, we have done thin spline method, thin plate spline method, we have done Kriging correlation method, and then we have the weighted average method. So all these methods are kind of interpolation methods. These methods are used to uh, make some kind of a uh, prediction of the data that you have. By using the data that you have, it tries to create more data points. So I like to use Kriging correlation because Kriging generally produces very smooth surfaces. So I like to use Kriging correlation. So I'll select Kriging correlation, and here you see that the number of columns and the number of rows that is there, it is pre-selected. If you want, I think you can adjust it by clicking here. So I will just show you what difference it makes if you change the number of grid points. For example, in this I will have 10 by 10 grids. I will have 10 by 10 grids, and I will click OK. This kind of sheet will be formed. So you see that I have 10 by 10 grid points, means I have 100 points, and using this 100 points, I will try to draw a there are different kinds of 3D surfaces that you can draw. You can try out each and every one of them. So this is basically a color fill surface. So it is a 3D it is a 3D diagram with no distinct color map. But if you want a diagram with distinct color map, you can choose this color map surface. So I will click on this, and it will look like something like this. So again, let me repeat the whole process by, I'll go to the worksheet, I'll go to the XYZ gridding, I will repeat the whole process, I'll make it to auto, I'll use the client rigging correlation, and this time I'll stick to the 37 by 37, and in fact you can make it more than that. So the algorithm, it calculates that okay, 37 by 37 should be sufficient, 37 by 37 number of bits should be sufficient for this particular diagram. It is being auto calculated by the Origin Pro. Let us stick with it. So now you see that I have a uh, square matrix that has 37 rows and 37 columns, and using this data, let me again plot the surface. Now looking at both these graphs, minimize this, let us see them side by side. So you see, this is the particular diagram that I had drawn. This is the particular diagram that I had drawn using a 10 by 10 matrix, and this is the particular diagram that I have drawn using 37 by 37 matrix. You see here the edges are sharp, here it has smoothed out. So it simply means that the more data that you have, or the more interpolation that you use, more number of grid points that you use, the smoother will be the surface. So like this you can make a 3D plot. Again, by we maximize this again using the same thing. I will also show you how to draw a contour. You can go, okay, you should be in this. Let me show you something here. Yeah. So whenever a particular worksheet or whenever a particular worksheet or whenever these are known as the M books. So whenever the particular worksheet or the mathematical books or M books are activated, they should show here as maximized, and everything other should be shown as the normal. So it means this particular M book is now activated. It is now maximized. So you can go to the plot and you can go to the contour and you can use a contour fill to have a 2D surface. So this is the 2D surface of the same diagram that we have here. This is the 3D surface, and this is an equivalent 2D surface. You can move around with this. You can play around with this, and in fact, you can also change uh, the symbols that are being used here. And double click on them, and you can change it from here. It is the everything else is similar, like whatever all the other diagrams that we have drawn, all the other graphs that we have drawn. You can directly click on here and you can type whatever the x-axis is, whatever the title of the x-axis is. Similarly in the y-axis also you can type and change. Similarly here also, if you want to change something, if you want to change the scale or something, if you want to reverse the order, everything is possible here. Similarly in the 3D plot also, if you want to write anything, you can write it here. You can change the axis labels. You can change the scale of the x. You can change the scale of the y. You can change the scale of the z. Anything that you want, you can do it here. And if you double click it here, you get some options here, like the color coding that you have. If you want, you can individually change this color coding also. For example, from less than 65 will be shown in the black, from 65 to this particular value it will be shown in this blue. If you want, even you can change this. If you want that from 65 to 70 it should be in this, so you can set this as 70, you can set this as 75, and so on. These are the auto calculated methods. Unless it is absolutely necessary, I recommend not to change this, because it has been so adjusted so that the a particular a good visual appeal uh, is there in this particular diagram. If you want, you can have some additional features like side wall. If you want, you can have the side walls here. uh, it depends on what kind of application you have. If you want, you can also have this is a 3D particular drawing, and if you want this projection on the ground, so what you can do, you can have a projection of this on the bottom surface. You see there now the projection of this 3D diagram on the 2D on the bottom surface can be drawn from here. And if you want only the contour lines, that is also possible. I think they are not visible uh, because they are shown in white. So let me change it to black. Yeah. So now you see that they are visible. And if you change it to 5, increase the thickness. So you see that the contours are all looks ugly. So let me change it to this. The contour lines are also visible here. If you want, you can switch on the contour lines. If you want, you can have the contour as well as the grid as well as the lines. So this is how it will look like. So you're free to play around with all these options and see what best suits for you and how best you can present your data. So in this course, we have covered the basic form of the graphs that we are going to use, the basic types of the graphs that we're going to use. Also, for some reason, suppose say you want to change uh, the view of this particular diagram, you can do that also. You can just click here, and here are some options available. For example, rotate clockwise, counterclockwise, all these options are available. You can do that, or you can also use the mouse wheel to, you can press the mouse wheel and you can use the mouse wheel to rotate the particular diagram as per your perspective. You can change the perspective of the drawing that you are seeing. Okay, so this is what you can do. Now we have discussed a lot of different types of graphs. um, we'll also see some important features like how do we export them, because this is the first part, or this is the first thing that you do, is that you draw a graph. but you also need to export them in high quality so that you can use them in your publications. So now you'll see them how to export them for any, this method is applicable for any graph, any kind of graph. It can be applicable for any kind of graph. So let me show for, suppose say for this particular graph, let me export this in high quality and show you how to export this. So what we can do is that we can go to the file. Once again, again the particular graph that you want to export, it should be maximized. Now it is maximized. I will go to the file. I'll go to the export graph option, and I have already set up my default. So every time I need to export, I just click on the default. But for this particular example, I will show you how to set up the default. You can go to the open dialog, and you will come across this particular tab. The first thing you can do is that you can click on the auto preview. So when you are calculating, when you are setting these things up, you will also get to see a preview here. So instead of the image, let me click on the graph. So every time you do some changes here, so you'll be able to see what is the impact of that changes on this particular graph here. So I've made the auto preview on here. So now there are different kinds of image types that are available. We can have them in different kinds of formats like BMP, we can have them in EPS, we can have them in TIF, and so on. Generally, I have seen that the most preferred image formats among the journals is the .tif, and .tif are very stable formats. So I like to have them in .pif formats. So I will have them in .py format, and now it is asking you which is the export, which item you want to export. For example, in this particular one, I want to export only this particular diagram, so I will have them in active page format is on, and I'll show you what are the other options available here. So again, you want to keep this as it is, because by default it will give the same name that has been associated with the worksheet or the graph, and you need to specify a path. For example, for my case, I like to have them on my desktop, and from the desktop I then copy it to wherever I want. So my default location is the desktop, so you can set up your default location here. And sometimes what happens is that two or more graphs may have the same name, so you want this to be in the ARCS mode, so that every time you copy or you export a graph to the desktop, and a same named graph is already available there, so the software will automatically ask you if you want to replace the graph or you want to rename the graph. Again, the theme may be different. For example, if I want this to be, if my journal wants this to be in black and white, I can just click on the black and white, and automatically the whole thing will be converted to black and white. And if I want it in the original, and there are some different options available here, so whatever you want in that particular format, you need to use it. So there are some other options available here. For example, the margin control that I have, it can be as it is, or it can be tight. Tight means it will be perfectly trimmed uh, at the boundaries. It will be perfectly trimmed at the boundaries. The most important settings that we have is this particular option in TIF. That is why I like the TIF option, because it gives me control over the DPI resolution. The DPI resolution is basically the uh, dots per inch. So the higher the dot per inch, the better is the clarity. But generally, the higher dot per inch is also associated with higher size. So 300 is a very preferred size by most journals. So I like to keep it in the 300. And to make the size of the particular files in less on your uh, hard drive, so I use the LZW compression. So what it does is that it compresses the file without affecting the quality of the file. And now what you can do is that once you have set all this up, okay, you need to do it only once. For example, suppose say the first time when you are setting up your Origin software, you need to set this all up as per your preference. And the next thing that you can do is you can go to this particular option and click here, and you can save as default. So from the next time when you want to export a graph, you did not do all this hassle. All you need to do is you can just click OK, and your graph will be exported to your desktop. Okay. So for example, for any other graph, for example, this graph that I want, now instead of repeating the whole process, I can go to the export and I can go to default. Okay. So the same settings, the 300 dpi .ti format, everything will be applicable for this as well. let us see, let us go here and let's see. Yeah, so you see this is perfectly trimmed at the boundaries. This is perfectly trimmed at the boundaries. The white space is minimized. Here also you see it is perfectly trimmed at the boundaries. This is applicable, or this is possible when you switch on the tight mode in the Origin Pro software. Okay. Other than that, I have just one last thing to discuss. For example, sometimes you want multiple graphs. For example, sometimes you want that you should have multiple graphs side by side. So this is the last option. So this is the last thing we'll discuss before closing today. So in this, suppose say I want my two drawings to be side by side. So what we'll do is that we'll go to the graph option. We'll go to the merge graph windows, and we can click on the open dialog. And as soon as you click on it, all the files that are there, it will be shown like this in the particular folder. So I can go to the specified and I can click on here, and the diagrams that I want to have side by side or combine, I can put it here. For example, this is the first diagram. Suppose say this is the second diagram that I want, and the other diagrams that are not necessary, I can just delete them by clicking here. I can just delete them by clicking here. So once you have this, now these are the two diagrams that you have. You want them in a one row format and two column format. I'll just type in here, and you want some spacings in between. So let me make this. So you want some spacings in between. So like this, you can merge multiple graphs into one graph. For example, like this, you can merge multiple graphs into one graph. And if you want, you can again label them with, suppose say this is the part A of the graph, this is the here for text inclusion, click here for text inclusion, you can click here. Okay, so like this, you can again set up your graph, and from here, if you want, you can again export the graph. Again, suppose say you want both of this is again an important feature that will work in all the graphs. If you want this particular A that I've written here and this particular here, these are on two separate lines, so I want them to be arranged on the same line. So I will select this. You need to select the reference first. So if suppose say this is the reference, I want this to arrange as per this. So I will first select this, and I will hold shift in my keyboard, and I will now select this, and I will use this option. So because I want both of them to be oriented to the left. So now you see they're in one perfect line. Similarly, I can repeat the process here also. And I also want that both of this should be also in the same line. So let me make this the reference. Hold down the shift button, and I'll click on this, and I can use this or this, anyone, to have both of them in the same line. So these are some uh, small tricks that you can uh, use to improve the quality of the graph or the quality of the plots that you use in your scientific publications. While graphing is only a part of the, or the plotting is only a part of the your publication process, but from a presentation point of view, a lot matters on them, because a good quality graphs and attractive graphs will attract more readers to it. And generally we should try to make the graphs more meaningful. We should try the graphs to be self-explanatory, that it should give out as much information on its own without even the reader referring to the text associated with it. Even with the text or the text description that you have put in the discussions or the results section, without even referring to it, uh, the reader should be able to visualize, and reader should be able to get the rough gist of whatever you have done here, or whatever you have done in the research from your uh, graphs and plots. So that's it. Keep trying this particular software. Origin. It's a beautiful software. You can even for some time ago, I think Origin Pro was giving free license versions for 6 months or something. I don't know whether the scheme is still there. You can search on Google. You can search on Google and it's on its website. I think that scheme should be still there for students and for academic professionals. But even if it's not there, the license is pretty cheap. As per the Indian currency, it is, I think it is roughly 5,500. So maybe we can you can try it out, the license version. Thank you for your time.